Hey there, thanks for tuning in to the Unit 9 video where I'm going to be reviewing the 3D formulas for different measurements. And we had two big shapes that we talked about in this unit. The first one was this shape, which is a rectangular prism, and the other shape was this one, which is a cylinder. So if you want to just jot those words down at the top, we had this rectangular prism, and over here the other big 3D shape that we explored this year was a cylinder, all right? Now, there were four formulas that we learned this school year, and first I'm going to talk about the volume formulas. I'm going to talk about how to fill up this box, and I'm going to talk about how to fill up this cylinder. So some key words here that I wanted to just review with you. You might straight up see fill the box. If it asks how many cubic inches or cubic units does something hold, that's us trying to figure out how much we can use to fill the box. You might also see the words inside the prism, like how much can be held inside of the prism. So these are all keywords here for volume, which is when you fill the box up. Now, friendly reminder about the formula and the way that this works is it says just take whatever the bottom shape is, take the area of it, and now simply multiply by height. So length times width, that would be this bottom rectangle. So we find the area of this, and then we multiply here by the height, and that's us filling up this shape. Now it's the same concept over here for a cylinder. We still take the bottom shape, this time it's a circle, and then we multiply by the height. So we'll find pi r squared, which is the area of the circle, and then we'll multiply here by the height, and we will have filled up the cylinder. Now some keywords here for filling up the cylinder. If it's a candle question, it might ask how much wax is needed to make the candle. If it's a soda can question, it might ask how much soda will that can hold. It might ask again about filling a can, or it could be a coffee mug or a water bottle. It might straight up say, kind of like inside the prism, it might say how much is inside the cylinder. And again, when we see how many cubic units does it hold, that's the same keyword as over here. It just depends on if we have a box or a cylinder, which one of these formulas we're supposed to use. Now, I wanted to also remind you guys that we're supposed to be using Desmos in this unit. And I don't have a screenshot of Desmos for finding the volume of a box because it takes just as much time to type in LWH into Desmos and then tell it, hey, the length is this, the width is this, the height is this. It's like, why would you do all of that when you could simply just multiply the length times the width times the height? So that's why I put here, I didn't put any screenshot for Desmos. I just left it blank so I could remind you guys it's quicker to just multiply. Now, if it is a cylinder question though, when we put it into Desmos, remember you want to use 3.14 as pi. Then you've got the r squared and then h, and then you would just need to tell Desmos what the radius of the shape is and then what the height of that shape is. So real quick, let's just review that the radius is the distance halfway across. Sometimes in a picture, I might give you the diameter all the way across, in which case you got to cut it in half. And we'll see a couple of examples like that in a second where we want to review. Okay? All right, now that was me going over how to fill up the shape. And again, it could be filling up a box or filling up the cylinder. Now the next two formulas that we see are when we're trying to cover it up for surface area, okay? So that's why we've got the surface area of the box formula and then surface area of the cylinder. You can see up here, it's got the SA for surface area and the V for volume. So what I'm doing right now is I'm talking about how to cover up a box, and then we'll talk about how to cover up a cylinder. Now, when covering up the box, your keywords that you might see would be like for wrapping paper, if we're trying to wrap a present and we want to see how much wrapping paper is needed. Surface area is now labeled with square inches, so it might ask how many square inches are needed for something. You might straight up see the words cover, and again, assuming it's with a picture of a box. If somebody's talking about painting a wall and you're painting 4 walls in a room, that's a surface area question. And then anything that it talks about being on the outside of the prism, that would again be surface area. Now, when you're putting it into Desmos, you can just tell Desmos this formula and then just come through and tell Desmos what length, width, and height are, and it'll calculate the surface area for you. And last but not least, when we're trying to cover up this cylinder, Friendly reminder in Desmos that anytime you see the pi symbol, you want to use 3.14. So we've got 2 pi r squared plus 2 pi rh, and this is the formula for how to cover up the cylinder. And it asks, again, how much aluminum is needed to make a can. That would be a surface area question. How much aluminum is needed to make a can? Doesn't matter if it's a soup can or a soda can, that's kind of the outside material of the cylinder, so that's going to be surface area. Again, I just mentioned outside of the cylinder. I mentioned the label of a soup can. Friendly reminder with the soup can, let me just kind of sketch one off to the side real quick, that if my soup can looks like this, you've got your 2 cylinders, and I know that's a little bit messed up, and then you just connect. The label is just this weird curvy part. So if it's talking about the amount of square inches that's needed for the label of a soup can, remember you don't need the pi r squared double, you don't need the top and bottom for that. If it's just for the label of the soup can, it's just this part of the formula, which is the weird curvy part on the outside. So just be on the lookout for problems like that when it's just asking for the label. Just be careful, you might not need a certain part of the formula. All right, and then again, square inches, as long as you know that it's dealing with a cylinder, it might say how many square inches are needed to cover the shape, and it might have a picture of a cylinder. And again, anything it's saying about covering up a cylinder, you know, is surface area. So you can use Desmos, and what I'm going to do now is I'm just going to have you guys flip over, and I'm going to show you guys how to use Desmos. First, let's focus on the surface area of all of these, and then we'll talk about the volume, okay? All right, so for surface area of this prism, I'm going to just come through over to Desmos, and I'm going to tell it the surface area formula, which is 2LW plus 2LH plus 2WH. You will have a formula sheet for this, so you don't need to worry about memorizing that. You just need to know how to read the shape to come through and say, okay, the length, this is 9 across. The width is 7 wide, and the height is a 6. And once we've told it the correct formula and we've given it the dimensions, we can get the surface area here is 318 square inches. Or sorry, square yards. Now, since I have the formula in Desmos, what I'm going to do is I'm going to come over to the next one, and I'm also going to find the surface area of this one, because I've already told Desmos the formula I want. Now I just need to give it some new dimensions for a new shape. So for surface area here, the length is now 9 1/8, and the 1/8 you probably remember is the 0.125. The width is going to be a 5 3/4, so let's make that a decimal, a 5.75. And the height would be a 4. There's nothing to convert there with a fraction to a decimal, so we're good. And for this surface area, we'd get a 223.9375. And just for the sake of simplicity, because I'm doing a review video, let's just take this 0.9 and bump it up, and let's just make that a 224. Okay, so 224. And then it'd be square meters. All right. So 224 and 318, those were our answers. Sorry, this 2 looks a little weird. Let me fix that. So we got 224. All right, and now what I'm going to do is just review the volume of these. Now we already did I mentioned a second ago, we told you that like length times width times height, like that's very silly to have to enter in. But since the dimensions are already here from this shape right here, I'm just going to leave it. So it's the 9 1/8, the 5.75, and the 4. You can see that I've got those in there. And we can use Desmos here. It'll automatically do it for us. Worst case scenario, you could just come through down here and say, okay, so it's the 4 and then times, and then 9.125, and then times the 5.75. That's for my folks who might just prefer to use the handheld calculator on that one. That would be the math that you punch in. We get the same answer. So 209.8, I'm just going to bump that up to be a 210. Okay, so the volume of this cylinder is 210. Let me change my color here. The volume of this one was 210. And now that we're talking about volume, remember we're going to switch it to cubic meters. Okay, cubic. Volume is cubed. All right, and since I still have the formula in here for volume, length times width times height, I just need to come through for this first shape again. We've got a 9, we had the width was 7, and the height was a 4. So I can delete that out, we don't need that. And it looks like if I multiply 9 by 7 by 4, those three numbers multiplied together is going to be 252. So the volume for this one is 252 cubic yards. So these shapes right here, notice in front of them it didn't ask for volume or surface area specifically. At the top, I just mentioned that I'm going to be reviewing how to find both. And if it's a word problem question, you're just looking for keywords to see, like, are we trying to wrap this box maybe? Like we want to wrap it and therefore we care about surface area? Or do we want to fill this box, in which case we care about the volume answer? The curveballs that they'll throw you are putting some fractions in here. But let's say you forgot that the 1/8 was the 0.125. You can still use the calculator to do 1 divided by 8. And right there, it gives you the 0.125 to remember that this would be 9.125. All right, so now what I'm going to do is I'm just going to clear out Desmos. And this time, let's start again with surface area, and we're going to look at cylinders. So in case you forget, you'll always have your formula sheet. We're looking at the surface area now of the cylinders. So we're going to do 2 pi r squared plus 2 pi rh. And I already reminded you guys in the video that anytime we see pi, we want 3.14. Okay, so it's going to be a 2 parentheses 3.14. We've got r, and then we're going to tell Desmos to square it. Then plus 2 parentheses 3.14. Then we've got an r times h. Now all we need to do is come through and tell Desmos what the radius is and what the height is. All right, so for example number 3, the dotted line here, it's pointing to just the dotted line, which is the radius, so we don't need to do anything cutting it in half. We're given the radius in that picture. And the height here would be a 1.5. So since we've got the right formula and we read the shape correctly, we can say here 75.6, I'm just going to round that up to about a 76, okay? So the surface area, let me go back to this one in blue. All right, so the surface area for this one is about a 76, okay, about 76. And since it's surface area, we're back to square yards, okay? Now, since I've already got this, again, the formula's in Desmos, I'm just going to leave this here, and let's review how to find the surface area of this shape. This time, it gives us the 6 with a line that's all the way across. So the 6 here happens to be the diameter, so we do need to take the time to just cut that in half and make that a 3. The height, though, is easy to read. That's a 10. And so for this one here, for surface area, we can see that Desmos gets us a 244.92. 244.92. All right. Now, if we're trying to find the volume, let me just switch colors here. If we're trying to find the volume of these, now we need to switch formulas, okay? So over here in Desmos, we can use the volume formula for a cylinder, which is this one. So pi r squared h. And let's make sure we've got, I'm going to clear that out. So pi is 3.14. R gets squared. And then we're going to tell it h. Cool. So now we've got the volume formula in there. And this one still has the radius of 3 and the height of 10. So it's going to calculate the volume for us right there is 282.6. So 282.6. This is meters, and we're dealing with volume, so this one's cubed. The answer up above, sorry, that doesn't really look like a 3. Let's fix that real quick. And the answer up above right here, this would have been meters squared for surface area. Okay. All right, and now we can go back to this first shape here. We've got the volume formula in there, 3.14 r squared h. The radius for this one was the 2.8. The height for that one was a 1.5. And so the volume for this thing is going to be the 36.92. And since it's a 0.9, I'm just going to bump that up to about a 37 cubic yards. So when you guys got the practice, when you flip over in a second, you're going to see that for the different problems, you basically got to pick. You're going to pick which of these 4 formulas are you going to use in Desmos, okay? Which of these 4 formulas do you use in Desmos? And then you're basically going to use Desmos to just crunch the numbers for you, and you'll fill in the blank to tell me the final answer. But out of these 4 formulas, friendly reminder that these top 2, these ones fill for volume, and these 2 cover for surface area. Again, it matters what shape you're looking at. Are you trying to fill a box or fill a cylinder? Are you trying to cover a box or cover a cylinder? And that concludes this video. Thank you for watching.